Welcome back, pre-algebra students. We're in lesson 3 today. We're going to talk about the parts of addition and subtraction. So when we have two numbers that we want to add together, for instance 10 and 4, both of these are called an addend. And they're both called the same thing because it doesn't matter. We learned a long time ago, it doesn't matter what order you add these two together, you're going to get the same result. 10 plus 4 is 14, and that result is called a sum. And I can illustrate this by writing over here 4 plus 10, you still have 14. So it doesn't matter what order, so you add things, you're going to get the same sum. So why give them different names if you can mix them up, right? They're all the same type of thing. It's different with subtraction. With subtraction, you have a number you are subtracting from. Let's say we have 10 and we're going to subtract 4 this time. The number that you start with that you want to subtract from, that's called the minuend. And the number that you are subtracting is called the subtrahend. And then the result or the answer is going to be called your difference. And it matters what these are, what you call them, because you can't just subtract these willy-nilly. You can't mix them up like you can with addition. It matters which one you are subtracting and which one you are subtracting from. So we are subtracting the 4 from the 10. You subtract the subtrahend from the minuend to get a difference or the result. So that's very important, and that's why they have two specific names. It's very important to know which one you're starting with and which one you're subtracting in order to find your difference or your answer. So that's why they have two specific names here, and you don't have two different names here because these can be mixed up and it's okay. So that being said, let's look at a way to find missing information that is not the sum or the difference. So let me clear the page. So let's look at example problem 3.3. We're going to find the missing number here. We have 472 plus a is equal to 628. The missing number is an addend. And the difference between the first addend and the sum is going to be the other addend. So what I mean by that is, in order to find the other addend, we're going to have to do the opposite operation. We're going to have to flip this around and turn it into a subtraction problem. So we take the sum here, and that's going to become the minuend. And then the addend that we know is going to become the subtrahend. All right, and then this will become our difference. So let's write it like that. So the minuend is the sum, 628, minus the subtrahend, which is the other number we know, in order to get the difference, which is the number we don't know. So when we subtract, we find that 8 minus 2 is 6, and we have to borrow from the 6. That turns into a 5, and this turns into a 12. 12 minus 7 is 5. 5 minus 4 is 1. This is our difference. Our difference becomes our other addend. That's what A is, right? So A was our difference. Now we can check this answer. We can say 472 plus, and let's take the addend that we found, put it here, 156, and add them together and see if we get 628. So that would be 8, that would be 12, carry 1, and that would be 6. Because it matches, we know that we found the value of A. So this equals A, and that is correct. And we did that by turning the sum into the minuend and turning the addend that we knew into the subtrahend, and that allowed us to find A. All you're really doing is taking this number and moving it to the top, drawing a line, and making this subtraction. That's all you're doing. You're taking the sum, moving it to the top, rewriting it as a subtraction problem with this first number that we know, and then finding the difference, and the difference becomes the other addend in the problem. Let's try another one. Let's try 3.4. Problem 3.4 says m plus 257 is equal to 493. All right, what number added to 257 equals 493? In order to find this, we're going to take the sum and turn it into our minuend, 493. We're going to take the addend that we know and turn it into our subtrahend, which is the number we're subtracting. And then our unknown number will become our difference, and we'll turn that difference back into an addend. So when we do the subtraction here, 493 minus 257, we find that we need to borrow, turn this into an 8, and this becomes a 13. 13 minus 7 is going to be 6. 8 minus 5 is going to be 3. And 4 minus 2 is going to be 2. So now we know the missing number, m, is 236, so we can check that. We could say 236 plus 257. See if we can add that together to get 493. And this is 9, and this is 4. So yes, because these two check, we know that the missing number is indeed 236. All right, and that's how we would do those. You turn the sum becomes the minuend, and the addend that you know becomes the subtrahend, and then the difference from that is the unknown value. And the unknown value is represented by the letter. We put that letter in there because if we were to use a number, it would be confusing because we would want to treat that like a value, right? You'd want to treat it like a number. So we put a letter in there to say, hey, we don't know what the number is, and we don't want to confuse ourselves by putting some number in here or some other symbol. So a letter cannot be added or subtracted, so that keeps us from making that mistake. That's why we use letters, because it's completely different from our number system. All right, so those are the steps. You turn the sum into the minuend. You turn the addend that you know into the subtrahend, you subtract, and the difference becomes the unknown value that you were looking for. So let's look at one more. Let's look at subtraction. What happens when we have subtraction instead of addition? Let's look at problem 3.5. In this example, we have 526 minus x equals 329. So if you guessed that we are going to do some addition, you would be wrong. We are not going to do addition. We're not going to do the inverse operation. Instead, we are going to flip the unknown value and the difference. So the minuend remains the same, right? Minuend stays the same. And the second step is to flip the difference and the unknown. So we change positions. So what we would do is say 526 minus 329 would equal x. And x becomes the difference. So let's solve that and say, let's see, that would become 16, right? We would borrow from here, making that 1. But we can't do that, so we'd have to borrow again, making that 4 and this 11. So 16 minus 9 is 7. 11 minus 2 is 9. 4 minus 3 is 1. So now this becomes the x value. That was our difference. And we can check our answer by doing a little bit of subtraction and saying 526 minus, we'll put our x in, 197, and we'll see if we get 329. So we have to turn this into 16 by borrowing 1 from here. And then we have to borrow another one because we can't take 9 from 1. So this becomes 4 and this becomes 11. 16 minus 7 is 9. 11 minus 9 is 2. And 4 minus 1 is 3. So because these two match, look at that, we got it right. So that is how you do a subtraction where you're subtracting an unknown. You would flip the two, the subtrahend and the difference. What if you don't know the first number? What if we don't know what this is? All right, well, let's try one of those. Let's do 3.6. Let me clear this. In 326, I'm sorry, not 326, 3.6, we're going to use some of the same information. Actually, no, let me find a different problem. We'll say P minus 423 is equal to 287. So what we're going to do here is completely flip the whole problem. Instead of doing what we did for the other subtraction problem, where we kept the minuend the same and flipped the subtrahend and the difference, we are going to flip this problem all the way upside down and turn it into an addition problem. So the difference and the subtrahend both become addends. And that's only when we don't know the minuend. So if you don't know the minuend, then we flip the whole thing and add it together. So unknown, first of all, unknown minuend. That's when you do this method. And if I could just manage to have decent handwriting for a minute. So the unknown minuend turns this into an addition problem. Use addition. So we would say 287 plus 423 would give us the answer P. So instead of, let me tell you exactly what we do. Difference and subtrahend become addends. And then that helps us to find the unknown minuend. And that's going to equal the minuend. Whatever that is, whatever that answer is, then that's what we could put in for P. So let's solve that right now. So 7 plus 3, that's 10, carry 1. That's 11, carry 1, that's 7. So we can check our work by putting this is equal to P. So let's put this in where P is and see if it works, right? See if the answer checks out. So 710 minus 423. Let's see if we get 287. So we have to borrow, make this 10. This would be 0. This would be 6 to make this 10. So 10 minus 3 would be 7. 10 minus 2 would be 8, and 6 minus 4 would be 2. So 287 is equal to 287, so that checks. So we got the right answer. P is 710. So when you don't know the minuend, that's when you turn it into an addition problem. If you don't know the subtrahend, it just flips, right? You flip the difference and the subtrahend in order to find the subtrahend that you don't know. So very cool. That is all we have for lesson 3. If you have any questions about this, please feel free to message me. I'll be more than happy to help you. Most of this should be a review at this point, probably up until about lesson 20. This should be something that you've already seen and you are just refreshing your memory. If you stumble between now and lesson 20, let me know so that I can help you get caught up and see where you are. All right? So I will see you in lesson 4.